For the next 45 minutes, I would like to share some of my work with you that I brand as extended reality for everybody. And it is, when I started here at the University of Michigan, I was working with a lot of students interested and familiar with user experience and interaction design. And as I developed my own research interests more in augmented reality and virtual reality, I noticed it's actually really difficult to create these experiences unless you have a training in, for example, computer science. And so part of my mission here at the university has been to allow and enable various designers, that includes user experience and interaction designers, to prototype and work with these technologies. And now, when you are in this area, you forget how hard a tool like Unity is. And so if some of you are more advanced in the audience, so I hope you can still empathize with the fact that it is not easy to create these experiences. So a lot of the talk will be sharing some of the techniques I've developed in the past, working with designers, non-technical, so not necessarily programmers. And then the second portion of the talk, I want to focus more on a new audience that I'm engaging, which is instructors. So people who teach any kind of topic and want to use AR, VR. So I also want to enable them to make use of AR and VR in their teaching. So I'll show you a video of what I do in some of my courses. So in an online series of courses that I've created, which I call the XR MOOC specialization, one of the things I try to do in my courses is actually use, not so much now over Zoom, but actually use AR, VR in these courses. So here's an example of me being in VR, but you get a mixed reality perspective on me. So I will get some of these terms out of the way very soon. And you can see how I explain the different concepts. I mean, the actual sketch of what I produce is relatively simple. I could have used a 2D sketch. But the interesting part is the instructor in this case is directly in the environment. And you can also see, if you wonder how we did this, you can also see that we shot it in front of a green screen, and that's actually not even technically necessary anymore. And so part of my mission is to enable other people, not just Michael, to do this kind of stuff for design and for teaching. And I want to give you the way I've structured this talk, and it may not have been the smartest thing I have done, but I wanted to give you an overview of the work that I have done rather than present some of the recent papers that I'm excited about. In this overview, you will see a little bit of my mission and some of the flavors and the research themes that I've been following. So I've listed them on the slide, and I've been very intrigued by the fact how most people confuse concepts like virtual and augmented reality even, and then adding a new term like mixed reality to what kinds of misconceptions that led. So I've been studying this. I've been studying key barriers to entry. It's been very fascinating to me. What are the main challenges for maybe non-programmers and hobbyists and domain experts and researchers? So I've been doing some of this more conceptual work, and I share two things here. I've been working on it, and most people who know me think Michael is the guy who builds some AR, VR tools and gets away with it, publishing them at Kai all the time. And that is true. There is some truth in it, because I do think building tools in research is something that most advisors would not necessarily recommend. It's a lot of work. On the programming, on the scoping side, but I wanted to share a few of the methods and tools I've developed in research to enable designers. And recently I've looked more into how do we actually enable people to collaborate in AR, VR, and there's interesting work going on at Berkeley and Stanford. And you have really cool, professionally trained computer graphics people. So some of the things I show you here, you will probably find it's not as technical maybe as, it's actually quite technical behind the scenes, but what I do not present is like new tracking algorithms or new sensing techniques that has been, or shape-changing displays. You have shown for that. That has not been so much the focus of my work. I've been really focused on enabling the design process and adapting it to AR, VR. And recently I've looked more into how to do this inclusively. So how do I actually teach in VR when not every student has access to a VR headset? I mean, there's those of us who say we design the future, and then there's those of us who actually live in reality. And the fact is that most students don't have access to VR headsets. So how do we design, for example, a VR course in an inclusive and in a safe way? And I'm also putting in some of the more recent flavors focused on privacy and security. So my trajectory has been making some of these more foundational contributions on thinking about the challenges and really driving a lot of the research within Kai to some extent. The tools, they are very dear to me, and each of them comes with, I think, a cool, clever idea, and I just wanted to share some of them with you, and really studying with different audiences. Don't go so much into the hard, like clinical settings or medical settings, but just shifting from designers and so non-technical. I mean, designers are also technical, but not programmers. And now recently working with instructors really has also shaped my thinking about how to use these technologies in teaching. So on the misconceptions side, I showed you a video where I was in virtual reality and I said it's a mixed reality view. So if you asked people, and we did this in 2019, what is mixed reality? When you talk about these terms, I've often sensed a lot of uncertainty about virtual reality and augmented reality. And so if you took an AR VR course, what your instructor would tell you is it's clear. There is the Milgram reality virtual reality continuum. This is the real world. We have an area where we see increasingly augmented content, so virtual content overlaid with the real world. And then there's something that is a little harder to grasp, but it's the inverse. It's augmented virtual reality. So you see mostly virtual content, but you incorporate elements from the physical world. And then you see the completely virtual world. So illustrated based on the video that you saw, I said you saw a mixed reality capture of me. So I was technically me was in virtual reality. Actually, this is the view I had on the top, bottom right here. And obviously it's an occluded headset, so I didn't actually see the environment around me. I did have a view on me that I could use to basically sketch against a mirror, a virtual mirror. And then obviously what it actually looked like in the real world when we recorded it from the outside is just Michael in front of a green screen. And this composition in the middle is really the essence of what mixed reality does. It creates a merged, the composite view of the virtual content and the real world, or the real person in this case. It's still mostly the virtual tilt brush environment behind me. And it can be a very powerful tool and you can experience the person in VR, but from a typical outside camera perspective. This composition can be done in real time. We do not need specific post-processing. Even with a green screen setup, it was done in real time. So when we ask experts, I just want to lay a little bit the foundation here for the lecture. The term mixed reality, you get different answers. Not everybody, in fact, out of our 10 experts, so these are 5 from academia and 5 from industry. And by 5 experts, I mean these are really senior professors in academia and really experienced researchers working for some of the main companies in the field. And they couldn't agree on the terminology, what mixed reality actually is. And we also did a literature survey, tracing back to Milgram's mixed reality continuum, reality virtual reality continuum paper, but also more of the industry sources, including Microsoft, how they hype mixed reality as a marketing gag. And so the numbers here don't really matter, but obviously there is relatively little agreement. We in fact found 6 working definitions, and then only a third of them in line with the reality virtual reality continuum. Most people thought mixed reality is just another term for augmented reality. There are people who think it's the combination of AR and VR, although actually technically Milgram specifically excludes. If I go back to the original slide, then mixed reality is a spectrum, but it doesn't actually necessarily include virtual reality. And so what I've done in the past, and more recently now, is just use the term extended reality to refer to everything where X is, so XR, where X is the wild card for AR, VR, and MR. And in fact, I stay away from using the term mixed reality because, as demonstrated by the research here, what people understand on this term is actually very, very different. Now, so what I advise to students, and obviously I'm not listening to my own advice because throughout this presentation I will use the mixed reality term quite a few times. But I use the term mixed reality when I'm really in between realities, or when I have an interface that can also be perceived in augmented and in virtual reality. And there are other notions like stronger version of AR, which is the more marketing-driven notion, and it's picked up by a few sources and also quite a few people. So anyway, we discussed this in more detail in our What is Mixed Reality paper. I think it's an interesting reading. We wrote this paper for anybody who wants to get started in this space. If somebody is excited at the end of this talk about AR, VR, could be a good starting point. We also provide we provide a framework to think through the space. And if you are trained in interactive technologies, you often distinguish interactive technologies based on input and output. That is not necessarily helpful when it comes to mixed reality, because if you think of the 6 definitions, the working definitions that were used by our experts in the literature, distinguishing them by input and output is actually not going to be helpful. So instead, we describe in more detail in that What is Mixed Reality paper a framework. So you would think along the number of environments, both virtual and physical, that the system wants to integrate. The number of users can have an impact on whether you would call something a certain type of mixed reality, the level of immersion and virtuality, and then finally, we would distinguish implicit and explicit interaction. And with these components, you have a framework that allows you to analyze existing experiences, and for those who care about terminology, it can be very useful. The other thing I've done is looking at current practices and challenges. And to be honest, when I started the research, I was excited about creating a few different tools, and with the tools, try out what could be better practices and challenges. And in fact, the more foundational research, the more survey-based or interview-based research on current practices and challenges, I've actually done a little bit more recently. So this is actually a Kai 2020 paper on creating augmented and virtual reality application, current practices, challenges, and opportunities. And this was a project not led by me, but by Nargis Ashtari, who is a PhD student with Parmeet Chilana at Simon Fraser University. Very exciting work. We interviewed 21 subjects that would self-identify as a range of professional designers, so trained in design, user experience, interaction design, or graphic design, domain experts. So these are people excited about AR, VR. They don't have a fundamental training in design or computer science. And hobbyists who really just pick up these technologies as they go. They get excited about them, and they don't have, like the domain experts, not necessarily the training that Unity, for example, assumes. And so in my work, I've been studying with these different kinds of user groups. And so there is more detail in the paper, and it would be its own presentation. But it is very interesting to think about where the challenges occur. I'm going to talk to you about the challenges. And you need to look at the fact how rapidly growing the landscape is in terms of devices and features, and new startups coming out and new startups dying, and Google changing its approach every day and discontinuing this and that. A lot of challenges with that. Around designing and prototyping, which is something that I've been focusing on, where a lot of the challenges are most tools are still difficult to use or have a very low ceiling, so you can't actually do too much with them. And so I've been tackling that mostly. And then there's a lot of issues around how do you actually implement and test mixed reality experience? How do I determine whether my new AR experience is actually good, for example, for teaching, and whether the user experience is good, so looking at new metrics. And so I'll show you some. I won't go over the details of this table, but I wanted to include it. What I would like to focus on is some of the key barriers to entry that maybe some of you, if you've done AR, VR before, maybe some of you have experienced those. It's very difficult to know where to start. And some people would just, most instructors just pick Unity as the tool and teach that to their students. That is not my approach. And I think the start has to be more fundamental with the concepts and really thinking through the space. But if you know how to use Unity, it is a good start. I'm not saying it's wrong. It's difficult to make use of online learning resources. It's actually, these technologies, while a professor will tell you they have been around for many years, most people, most practitioners would tell you is actually they're cutting edge or bleeding edge technologies. And actually as it is often the case with these new technologies, the online learning resources are very quickly outdated or insufficiently documented. So it's very difficult to actually work. If you got your hands on your latest new Quest or whatever, and then you try to work with the pass-through API that was released 2 weeks ago, you still can't find useful documentation. But you see hobbyists and in some sense amateurs, so not directly from Facebook or Oculus, who publish their GitHub projects where they got the pass-through to work and share it this way. Now, when you have an example like this, it's actually very good for an expert to learn from those examples, but for a novice, it's actually very hard to learn from examples. Most examples are too complex and not easily adaptable to their problem. And so I've been studying this as well in some of my research, but I didn't make it a big focus yet. The two things I want to focus on is really, it's very difficult to design for the physical aspects of immersive experiences. And it's very difficult to plan and simulate motion in AR unless you are in AR and you have access to these AR, VR devices. And it's also challenging for an interaction and user experience designer who has been mostly thinking about 2D user interfaces and menu-driven or kind of website-oriented experiences where you have relatively straightforward navigation paths. It's very difficult to design a story-driven immersive experience. And so I want to show you for the next 10 or so minutes, I want to take you on a little tour of some of the things I've been working on. And that is tools and methods to create these experiences more easily for some of our user groups that I just mentioned, including professional designers, but also mostly novice AR, VR designers. So the tool landscape, and this is actually from a review I did in 2018, you can divide it into, maybe you see a tool that you have heard of or are familiar with. I would say the tools that allow you to do the most AR, VR, so the highest fidelity, are obviously also the hardest to use. And while we have increasing support in more traditional interaction design tools like Vision Sketch or Adobe XD or Figma, the things you can do on the AR, VR side is actually still very limited. There is a whole range of tools that maybe some of you are familiar with, which are immersive authoring tools. So you're in AR or VR, and so you experience concurrent design and testing. And there are some, those always look very cool when I show you a video. It's similar, I actually used one in my video before. I was inside Tilt Brush and I was sketching out that 3D world. They're not useful for prototyping complex AR, VR experiences. They're good for storyboarding them and brainstorming. Microsoft Maquette is maybe an exception because they are becoming a more UI-oriented tool. In any case, in my research, I've looked at, and that's the dream, I guess, and the skeptical reviewers probably think I did not accomplish this, but I see myself somewhere down here. I find that area very interesting. So obviously you want to achieve a high level of fidelity, maybe even matching some of these more programmer-oriented tools, but you want to keep the skills and resources required relatively low. And obviously this seems like a really cool thing. I think you could critique my work and say very clearly, Micah, at best you're like here. But you would agree with me that maybe the skills and resources are definitely, we saved some there. So I'll show you some of these. This is an exploration of, young Michael getting started in AR VR in 2016. So I'll show you actually an example of, and I wanted to play sound. Now, if it's too loud and not so pleasant for you, please interrupt me, but I'm gonna play the sound a little bit. and I need to share the sound. And I wonder whether it's too loud. Okay. So I'll make it a bit softer maybe. So a lot of the techniques I'll show you in the following segment are coming together here. So I've worked on a lot of paper prototyping techniques, which are familiar to you if you have done interaction design courses. We use Play-Doh and physical materials quite a bit. So, some of you may guess already what we're creating here. So what we are creating here together with my students is a $25 version of the $250 million version of Lion King. You can see some of the themes in comparison. This one was the hardest scene for us almost. We had to use slow-mo. And quite cute actually. I still get goosebumps when I watch this video, but I'm looking at the Play-Doh version. I know you're looking bottom right and you find it so amazing. Disney, great. And Michael's stuff, not so great. Okay, and obviously the sound we didn't actually, we stole it from Disney. Kidding. This is a YouTube trailer, so it's fine. So why did we do this? What were the techniques I just showed you come together? So the Lion King, and I will come back to the Lion King example. Let me actually change how I share the video. We can optimize for slides again, then maybe this reads better for you. In this Lion King example, Lion King is interesting because it's a movie that was done in VR. In fact, it is a virtual production. Rather than record images through the camera, you track the camera and you record the traces of the camera. And at the time they were recording the Lion King, they had what we call a pre-visualization. So they had roughly the characters in there, but they didn't look as nice as they look in the final render. And so it is a very interesting way to think about the future of filmmaking. And maybe you got excited by the Mandalorian and you've seen things like that. So virtual production is very interesting. And we wanted to study what actually goes into creating prototypes like one of the Lion King. And I want to show you a little bit more on what we can just do with physical prototyping. So initially in my work, I've created a tool called Proto AR, where what the user can do is sketch out an experience on paper, then use a few digital techniques to import it into the computer. It uses an interesting combination of smartphone and desktop. And it's a tandem interface. So you work with the smartphone to capture things and preview things in AR. And you do the hard task like placing elements and modeling and stuff on the laptop. And so in 30 seconds, I just created this was cut together. In 20 minutes, more likely, I would create an AR furniture placement app like IKEA Place. And so I've been working on techniques that allow you to very quickly create mobile AR mockups from paper. At the time, we were using marker-based AR. You can see that a little bit. And then we developed some techniques where you essentially recapture a couple of times and can create very interesting interfaces by coloring and cutting out, so using techniques to remove some of the background. And then we can also capture Play-Doh models. And we don't do, so Manish Agrawala, who's an expert in computer graphics, is somebody who would be very familiar with 3D reconstruction of some of these elements. The elements at the time, the Play-Doh objects are very small. The idea is you prototype at miniature scale rather than life size. And so 3D capture of small objects is hard. So we developed a relatively simple technique where you fly around the object in 180 degrees or a 360, and we capture the angles on the object and replay these different angles, kind of like as perspective frames. When you view the thing in AR, and it gives you the illusion of creating an AR experience, but you cannot see the objects from angles that you haven't previously captured. Anyway, so this technique is relatively cool in a class because on commodity standard smartphones without any AR capabilities other than a webcam, you can create AR experiences, and that was the point of this project. And I always like to show some of the creative art that my students did. So you see Ariel, one of my favorite sofas, and really also details that are hard to model. I mean, unless you're an expert, like creating a blanket in a 3D modeling tool is actually quite hard, but doing it physically with Play-Doh in our studies was actually fun. The students, in fact, were discussing the rest of the mobile experience while they were modeling some of the characters. So we've done a lot of design jams in my lab. Really, for me, it's always cool to show this work and see what we've been doing. Anyway, so I took it further into this idea of paper prototyping and testing. Might be another thing that you are familiar with if you take some of the interaction design courses. So how does that look like for AR VR? So I will show you some techniques. So we will use a specific template to design in 360 degrees around an AR or a VR user, but we still have the idea of a person that is communicating with the user and facilitating the user study. And we have a person that is, as Margrethe called, a computer in quotes, who is actually responsible for producing the interface for the user. The facilitator has the additional task of capturing whatever we put on the template. Now, with this approach, what kinds of experiences can we create? So I'll show you a little bit more of the template. Again, this is the principles behind the template are 360-degree photos. Take this sheet of paper and wrap it around the user, and then at this edge and this edge would basically be coming together behind the user. So if I model an experience, like let's say I want to have a few butterflies here in front of the user, and I want to put the user in a scenery with trees and then maybe mountains, you can compose this experience from 3 layers or more. And then you can use our tool. I'm sorry. Not sure what just happened. I think I pressed the wrong button, but I hope it's still playing for you. And you can create a parallax effect by just, increasing or decreasing the space between these layers, and allow, even though this is flat, it's essentially drawn on paper, we can make it a virtual reality experience. I mean, I show you a 360, but you can also see it in VR on a headset and allow you to experience that paper prototype. So I was very fascinated. I didn't invent the concepts of 360, but I was fascinated in using these as a way to prototype. And so this is what happens behind the scenes. You do need to sketch the layers according to the template, and some of these distortions are a little tricky. So we didn't invent new tools to deal with that. And then you map it onto spheres and layer these spheres, and you can adjust the distance between the spheres and the opacity to create these layers, and then you can experience something like this. You could walk through one of my favorite examples is this Star Trek that we created. It's the next generation. If you're a Star Trek fan, maybe this will look familiar, even though it's a paper prototype. And using then AR, you can actually walk inside your paper prototype, which is cool. And I showed you before how we can layer an experience into foreground, midground, and background. And we can also create this room effect by moving one sphere further away from, so not having them all intersecting with overlapping with each other, but actually intersecting them with each other. We can create a room. And this is what we essentially did here. So one layer is the bridge, the captain's chair, the bridge. And in the second layer, we created the observation desk, which is this room. And we did a little bit of cutouts here and inserted the virtual background. However, this virtual background I remove in AR. So the user can actually then see the real world through it. And so with this tool called 360 Proto, we really explored how to make these paper prototypes interactive. And I'll show you some of the more experimental but still fun to look at examples to see how far we can take it. So here we can prototype an Amazon shopping experience where we place furniture that is essentially drawn on a paper sheet and displaced relative to the user. Another thing, one of our crazier prototypes was recreating this record experience where my student Katie, who was a co-author on this paper, she is using the racket and I am the tennis ball, and I was moving the tennis ball on there's a lot of things going on. I want to show this one more time. Oops, I went too far. Damn it. Let me play this one more time. Because I want you to see the toothpick, because I want you to appreciate the role I had in this experience as the, and it's a little toyish, I guess, but to me it is cool to see with relatively simple means. Okay, furniture again. But now, okay, so we implemented first to get an estimate of the effort. This is a VR experience with physics. And so as a wizard, you can see here on the bottom what I'm doing. I'm moving a toothpick with this little tennis ball cutout thing on my toothpick, and I'm moving it relative to Katie on the template. So it requires some coordination, but actually quite fun. So I will reshare. I'm still sharing. I will represent. Present again. So the last thing I wanted to talk about is some more of the collaborative work that I've been looking at. And so far you could say, but Michael, your experiences are very simple. The interactions are quite limited. And I know, and I've looked into prototyping gestures without programming and using Wizard of Oz and crowdsourcing. But in the interest of time, I've decided not to present this here. But Gesture Wiz is a paper from 2018 that I've worked on, and it's actually pretty interesting. And I was also intimidated by all the cool stuff that Michael Bernstein is doing. So he is Mr. Crowdsourcing, or used to be at least. So anyway, I will focus on collaborative authoring and coordination. So coming back to our Disney example, so we took actually, if you're a PhD student and sometimes deal with reviewer comments, so this work was really hard work. We took to WIST where it was destroyed by one person who said, this is crude programmer art. And so if you feel the same way, then I can tell you I've heard this before. But the principles are what matters. We are not Disney. We had a $25 budget for the physical prototype and a $2,000 budget for the digital prototype. And so we prototyped some of these experiences digitally, but we did it while Michael, now me, I'm the director, and we are recreating a scene where Rafiki, inhabited by our actor Jane, who is in a VR headset, walks up Pride Rock, not exactly like the way it's done in the movie, but a little bit similar idea. And Katie is our camera operator, so our cinematographer. And interestingly, she uses AR. So she uses an AR device to simulate and actually move this virtual camera. And so I'll show you an example of what this looked like from some of our test scenes. Good acting on Jane's behalf. The camera is relatively static. And I said cut, and I complained a little bit, and we reshot this scene a few times. But I also want you to see what it looks like for the viewer. The experience we actually created. So it's a little dark here because of our crude programmer art. We have a Google Blocks, a Google Poly model, Rafiki. And the camera movement, I wished it were more pronounced. So I gave feedback to Katie, you need to move the camera more, and we had to deal with the scale. And so what I studied in this work was coordinating multiple designers who are co-located using AR or VR, and I've explored different kinds of spatial coordination challenges that they would experience, and physical constraints are obviously the predominant ones, and you could get a bit of a sense of that just now by me instructing Katie how I wanted to use the camera, her to use the camera, but we had physical space issues, and so we built inside XR Director, we built a few tools to rescale and reposition and recalibrate without restarting the experience. So it's kind of like a cool paper, has some interesting technical elements to it. But what I was most excited about is, like, to me, it's one of the conceptual contributions of the paper are really a framework to think through spatial coordination and mixed reality, but using it as a groupware. And collaborative AR/VR is actually one of the hottest topics right now at Chi and WIST. And so I wish more people would build on this work like XR Director, which I think is can be quite interesting. So the thing I've learned, and I want to move on to dealing with the research that I'm doing with instructors right now, is less published work, and so more work in progress. But so the things I've learned so far is the tools I've created, very good for design space exploration. Rapid prototyping is definitely something that works and accelerates design. The templates we've used, they guide design, but using them is still difficult. So there could be more research on more clever authoring techniques, and maybe you can draw more 2D, and then we can map it onto a 360 or a 3D sphere, and we can support your creativity that way, because following the distortion lines is pretty hard with some of the templates. Anyway, it's still oftentimes for end users, it's still difficult to imagine. They see it's a paper prototype, even though I was excited by the Star Trek. Your client may not see that. It's still difficult to imagine what the final AR/VR experience would be like. So, but I think we're making good progress on the fidelity side, but it doesn't replace an implementation. And Wizard of Oz enables more, goes beyond a low fidelity, but these interactive experiences still require a lot of coordination. So this XR Director work is something that I think is a good starting point to explore more frameworks and more tools. And Björn Hartmann's group at Berkeley, Bala, he's doing amazing stuff over there, a PhD student on mixed reality and collaboration. So it's not too far away from you. So in the next 5 minutes, if that's still okay, I wanted to show you what I've learned from working with instructors. And now is the part of the presentation where I feel like I talk too much and I'm running low on time, and I had planned more content. So I will pick two things. One is, I will talk you through this one experience. I may not get to the privacy stuff. So anyway, maybe if there are questions, we can talk about this. So creating, one of the things I've done also for Chi 2020 was creating a toolkit to support mixed reality analytics. And we demonstrated this toolkit is useful to support designing learning activities. And so if you, in this case, you don't see exactly what the students see. Obviously, we are in a lab environment, but they see an immersive simulation. And what we did was we worked with a nursing instructor here going through a tabletop triage exercise where my lab, including myself, we were given the scenario of arriving at a disaster, and we had to determine which of the poor people we need to take care of and which of the poor people at this disaster we can't do much and we should therefore not prioritize. And there's a triage protocol for that. And it's an interesting experience that you can do through a tabletop exercise. But what the instructor really wanted is an immersive, a mixed reality experience. So we went ahead and designed a virtual environment, and we scoped it out using some of the immersive prototyping tools and techniques that I've talked about previously. Here's a rough, a previs of, so you come into this escape room, and there's a crisis in there. There might be some people who are injured, and it's also bad weather, and it's a little bit of a war zone. And you need to escape this room when it's safe. So you need to pay attention to when the shootings stop and determine when it's safe to get medical help. And so we prototype this experience using Unity, and here you see how it looks on a computer. Then I'll show you in a second what the actual experience is designed for a HoloLens, where the students wear a HoloLens, so it's an AR headset, and they get to see, we map some of the content into the lab. We see, unfortunately, some people who didn't make it. And it's a timed experience to create stress. And it's also an experience where you increasingly see injuries, and you get triaged, and we can display these injuries on t-shirts that we created using marker tracking. And here you can see some examples. They shouldn't look too bad. I will show some injuries, but I try to pick portions where the injuries don't look too realistic. They look more like bacon. So we have two versions, two levels of bloodiness. If you're a medical student, it's no problem for you to see glass sticking out of a body or a bone. And if you're not, it is actually not a really pleasant thing to look at. And so we have created tools to track what's going on in this immersive experience, and analyze for instructors how the students behaved. How would you even assess how different students perform in this simulation? And so we created this toolkit to enable instructors to essentially conduct some of this work in their classroom. And there's more work on how to track things and analyze things that I would refer you to the paper. It's interesting so I've talked mostly about design before, and design includes evaluation. And I've also been looking at some of these tools in that space. And I feel like I should make room for questions. Sean, you should decide with me whether I should show one more thing for 4 minutes or rather open the floor.
I think you can show one more thing for 4 minutes.
Okay, then I will do that and then stop really at 50. So it is recent work that I just presented at Kai, so it is interesting. So it's coming back to the original video, and it would be a nice way to wrap up the work. I wanted to enable instructors to teach directly in mixed reality. So I created this tool called XR Studio. And it looks a little bit like this. So XR Studio is inspired by streaming software and virtual production software. And as the instructor, I'm the instructor in here, I have different presets, and I can, while I'm giving a lecture in VR, I could just show traditional slides, or we could have an activity like here with my students. And then I also have mixed reality capture support for different kinds of whiteboards. Here, what I'm showing is kind of like what I would call a light board, where I'm actually sketching against a window, and you can see me in the background, the real person. And then we also can have very interesting experiences. Like here, I sketched out how a perspective camera works, but I sketched it out relative to the perspective of a student. So this is what they would see in virtual reality. So it's collaborative. It's a lecture in VR that you can perceive through a camera, through mixed reality capture, but you can also participate live in it in a VR headset. And so XR Studio, it's called XR because it supports these different types of modalities and cameras. We can do AR, we can do VR. And I think it's really kind of like a cool tool that I'm very excited about using in more teaching here at Michigan. And I would have more studies and things to share. The immersive views and the mixed reality capture was definitely, I gave the same lecture 3 times. I'll stop sharing here so that you can feel like Michael's really wrapping up and on time kind of. So I am teaching AR VR courses, and I have given one lecture 3 times as part of our evaluation with XR Studio, more traditional using slides, more VR centric, so from a first person instructor view, and then using the different features of XR Studio as our virtual production tool designed for instructors. And some of the nicest comments I've heard was like, it felt like being in a real classroom with the mixed reality capture without the overhead of having to have access to a VR headset, and still understanding spatial concepts. Like I explained how texturing works, or how scale works, or how a perspective camera works in AR VR. And that was, to me, was very promising that the students felt the benefits of immersion, even without being in a VR headset. So I'll stop there before I overclaim and throw it back to you, Sean. Thank you.
Great, yeah. Okay, wonderful. Thunderous applause here, if you can hear it. I'm not sure. Great, so now we have time for questions. And so we're gonna do this in a sort of hybrid format. So we'll try to pull some questions from here and then also on Zoom. And so if you're on Zoom and you want to ask a question, use the raise hand feature, and then we will then call on you, and you can either type your question in the chat or we'll allow you to unmute yourself, and you can do that. But as people are trying to figure out the logistics of the online questions, are there any questions in person here? And yes.
Hi. This is maybe a more meta question. Can you hear me well?
I think I can hear you well. Thank you.
Okay. So when there's an area of scholarship or maybe a platform that is difficult for outsiders to grasp, for example, here, VR and AR, do you see a framework for a scholar such as you to try and make it more accessible? So you've shown how you've done it in your particular case. If someone else would like to repeat the same thing in another area, perhaps even non-technical, what might a good approach be per your experience?
Yeah, that's a very cool question. I'm thinking of a few things. So some of the things I've done, which is I think you need to, when I walked around at Kai and asked everybody what mixed reality is, which was the precursor to the actual research project, the community that was publishing papers on mixed reality didn't really agree on the terminology. And that to me, so like critically reflecting on what the community understanding is, and then actually studying your own community is actually, so science of science, I think is actually a very, very important thing. From time to time, you need to ask whether we are still talking about the same things. And so that's one thing. The other thing is, in a lot of my work, and I wasn't able to show that too much today, I built experiences that, like an interactive handout using AR, VR, that I can then give to an instructor who we've worked with experienced college teachers with average years of experience of 30 years of teaching math or physics in high school. And this is this is very interesting type of user to work with. So how do I don't want to impose new practices and workflows. They have not really used AR, VR before. How do I get them to imagine? I cannot ask them directly, do you need AR, VR? They will tell you no, because they've been teaching for 30 years and it worked fine. So how do I get them to imagine what could be possible? And so in a lot of my work more recently, I've been more focused on co-design and working in participatory design. But the interesting challenges you have when you work with people who have not previously experienced AR, VR, so priming techniques, elicitation studies, which is a technical term. Those are, I think, very good techniques and tools to help shape the community's understanding and also allow new people to come into the area. Obviously, finally, the tools I've worked on, part of my dream was that the tools themselves would enable more, I use them in my teaching and they enable more students to do things. But I think the reflecting on the research approach is very interesting. So I thank you for your meta question. I thought it was cool.
Nice. Any other questions here? Yeah, in the back.
This is sort of a broad question, but what are your thoughts on the metaverse and how far away do you think we are to entering sort of a reality where we all engage in the metaverse as well as the real world? Yeah.
So fundamentally, I do not believe it will exist because it's very interesting. So you and I may be in the same physical location, but then depending on our preferred cloud service provider, you and I may not see the same thing. So if we both run with Amazon, we may see the Amazon AR cloud or the Tesla AR cloud. And so this metaverse, this dream of living together in a virtual world that is essentially be controlled by different entities, and Facebook and Oculus might be one of them. I find it very difficult. Think about how cloud storage works and how we, like, is it on Dropbox or Google Drive? And then, but it's worse because you and I, if you want to look at the same stuff while we're in a physical location, it should be tied to it. It's AR. And I don't know. And then, I mean, I have seen many Black Mirror episodes. I think it is fascinating to imagine how life could continue in a virtual reality. I like the movie Upload or that series Upload. These are interesting glimpses at the metaverse. More fundamentally, the metaverse as a term suffers the same challenges as mixed reality. It's overhyped, it's not understood very well, and it's actually not really well realized. So I am skeptical that we will achieve that vision. It's like, did we ever agree on one computer to do everything? So it will be a market share problem, and it will actually lead to a lot more. I think diversity, equity, and inclusion will actually be very pronounced in this metaverse. Referring back to Upload, I like it when, and I don't want to put in any spoilers, but essentially, if you only have a 2G connection to this metaverse, your experience will be very sad and very black and white. And if you subscribe to the best cloud service provider, you will get the best AR experience. On the other hand, it's not too different from real life. So if you can afford a good medical doctor, you can go and get the best treatment. We essentially just replicate that. So it's a very philosophical question, a very cool topic to talk about. I hope I shared some of my perspective with you.
Great. I think we have a question online from, if you can either unmute yourself, ask to be unmuted.
You're unmuted.
Go for it.
Hi, Michael. Regarding XR Director, I'm a little bit confused. Is that for creating a VR experience, or is that for creating like a 2D animation?
Oh, yeah, that's right. So if you think about The Lion King, essentially it was shot as a VR experience, but it's delivered as a 2D movie. And so XR Director, the work was really focused on studying how different designers in AR and VR could collaborate, what that would mean for the director, and the resulting output can be a 2D or a 3D model, but 2D movie kind of thing, like with The Lion King. But also with XR Director, we could actually record everything that is being created and animated inside in 3D. And so we recorded all the traces and animations that were created. And actually XR Director also exports scripts and assets. So it is also a prototyping platform for AR VR experiences. So the answer is yes in both cases rather than one of them.
Okay. The only thing I might imagine could be problematic for creating VR experience is your camera might not be able, you can't manipulate your camera angles that much in a VR movie as in like a real movie. Right. So
in fact, for the camera, there was a preference towards using the AR mode of XR Director to move the camera. And for VR, I've implemented two types of cameras. One is you use your head as the camera, or you get something put something on your controller as the camera, which gives you, it's a different perspective when you're shooting as the director in VR, but it gives you more freedom with the hand. So he is very experienced, so he's touching on some of the critical points. But we thought of that, and I'm happy to share more with you in our meeting later.
Cool, thanks. Sorry, I can't start a video for some reason. I can only unmute myself. It's weird.
Great. I think basically we have time for one more question if there is one here or online. And I have a question too if we have time. Did you want to ask a question? No. Your question got answered. Yeah. Okay, so great. This is the last question then. So I'm wondering, this is kind of somewhat connected to maybe the first question in terms of, you talked a little bit about, there's this extended reality experience that you're going to have through these different types of headsets, but then the medium that people are experiencing, it seemed like was a little bit different in some of these different tools you were showing. So some of them were sort of, as pointed out, like a VR movie or XR movie. Some of them seemed more like XR games. Maybe also you had some XR VR tools. How do you think the medium of the experience changes the tools, and can the same tools support these different mediums, or are there kind of unique differences that we need for these different types of media?
Yeah, so I think a lot of trying to find out whether AR VR is actually a good tool or media is actually, Sean, the last question is like the hardest. It's interesting. It's a chicken and egg problem. I think. I wanted to be agnostic so some researchers think of themselves as VR researchers or AR researchers or have a preference. I approached both topics, and I think I do that in my role here as a faculty innovator with the XR initiative at the University of Michigan. I'll do it the same way. So when depending on the type of experience you want to create, embodied cognition in VR, so immersion might be the right tool. For other projects, so meditation projects, a lot of my students work on meditation, mental health, so we often choose VR. But I find it interesting to also explore what AR could be, and so I think these mediums are also shaping along with the tools. Most tools traditionally used to be either AR or VR. And you will also see more increasing tools you can design for both. And in fact, it is often just a matter of adapting the interactions and switching out the display and tracking aspect. So
yeah, I guess my question is maybe less about the AR or VR or mixed reality and more about the type of experience, right? The movie or the game or the tool sort of require these different interactions or different ways of thinking about it. And I wonder if, how much can a tool that helps you create mixed reality movies extend to a tool that helps you create a mixed reality version of, Tilt Brush, for example.
All right. Yeah. So that transition is still, it's still hard. I think it's still an open research problem. Like you're speaking. Roughly, maybe. I'm still not sure. I catch it really. On the fact that a lot of these simulations that I created in these prototyping experiences with Wizard of Oz, they essentially die more or less with the present. I don't think that's asking either. So, Sean, I need more time to understand.
We'll talk more. I like it. It's great. All right.
And I'm sorry that I couldn't get it exactly what you wanted to know.
Yeah, we'll talk more. It's great.
Thanks.
No, so wonderful. Let's thank Michael for the wonderful talk.